In this video, we are going to discuss about chain silicates. So, what are these chain silicates? So, chain silicates contains anion which is found by sharing two oxygen. These things I have explained while explaining in the board only. In second video, I have explained, right? Two oxygen atom they are going to share with each tetrahedron unit, right? So, if I give you the structure, you will get to know. For example, see here. So, what happens is that here silicon is there, right? To that it is attached to four oxygen, one, two, three, and above one four oxygen, right? So it will form chain like this, like this. They will form a chain. So this oxygen is there, right? So this oxygen is again shared with one more silicon like this. So here again four oxygen, and this oxygen is sorry, and this oxygen is there, right? So this oxygen is again shared with one more silicon and four oxygen, and this oxygen is again shared with one more silicon, right? Similarly silicon for oxygen, like this the chain keeps on moving, right? So the dot represent, this dot represent silicon and sulfur represent oxygen. So this is chain, they will form a chain like structure. So I can join like this for like this, right? So I can join like this, right? So I can join like this, so it will become so clearly you can see now. So we'll get like this. So negative charge you can place here. So here this oxygen negative, this oxygen negative. This oxygen again it is bonded to silicon. This oxygen bonded to silicon. So we won't give negative charge because it has got two bonds, right? And other for other oxygen here also negative and negative, negative and negative, negative and negative, negative, negative and negative. Like this, they will be n units. If you see, so we will have the formula like cyclic silicates only, SiO3 n to n minus, right? So this will be the formula for this chain silicate also, same as cyclic silicates, right? So this will be the unit like this, how it will happen, right? So if I want to write it simply, it will be like this. See, like this, you will get chain silicate, right? So this is how we will get. So nicely you can decorate it like this. You can decorate it. See, so sweet. Wow, like this we will get chain silicate, right? So let us see few examples. So here only for this formula only SiO3 n to n minus, if n is equal to 1, so I'll get one name. Let me name it. So that is nothing but, I don't know how to pronounce, n statite, sorry, n, let me write it, n stay tight, TITN stay tight, and it's for, it is nothing but magnesium silicate. It is magnesium silicate, and its formula is uh, MgSiO3 for n is equal to 1. If n is equal to 2, we have so many examples. For example, here you can remember spodumene, spodumene, and it is nothing but lithium aluminum disilicate, and its formula is LiAl, right? SiO3 twice, so it is disilicate. For n is equal to 2, other name if you want, that is Za, Zaite, Zaite. So Zaite, it is nothing but, sorry, yeah, it's same. Here lithium aluminum disilicate is there, but here we have sodium aluminum disilicate. So sodium aluminum di SiO3 twice, that is nothing but Zaite. Spodumene means lithium aluminum disilicate, right? So if you remember any of the two, you can give it, right? For n is equal to, if you want an one more name, I can give it to be this is diopside, diopside. So its formula is calcium magnesium disilicate. What is that formula? Calcium magnesium disilicate, SiO3 twice, right? So these are the minerals we can call, right? This is how these silicates, chain silicates, are available in our earth crust. It can be in the form of soil, rock, uh, like this we'll get these minerals, right? So these are the examples, you can remember any of the two, right? So this is how you should remember. In next class, let us see about sheet silicates and their general formula.